everyone. Today we are going to explore two methods to work with outliers. As you can see in this visual, we clearly have an outlier, which is our pen. Because this is so much higher, my other values are not having much significance. And to fix this, we are going to explore two methods. One is with logarithmic scales. When you go to the format option, in y-axis you have this option of logarithmic scale. If you click it, your values get compressed. So now this outlier value is not dramatically standing up against all these other categories. While it looks higher, these values also are having their own significance. So this is one method. The second method is by using z-score. So what we are going to do is we are going to create a slicer with two options. One is show all and others exclude outlier. When the user selects show all, they will see this visual, and when they are selecting exclude outlier, they are going to see only these four categories. Okay, so let's start that. We are going to first enter data to create our slicer. So this will be called filter. My first option is show all, and my second option is exclude outlier. Okay, I will load this into my model. So now we are going to dynamically calculate an outlier. Anything could be an outlier. Today pen is an outlier, tomorrow pencil could be one. So we are going to dynamically calculate it by using z scores. So first here I will create a new measure. My z score 2, because I have one already in my data model. I'm going to start off by creating a measure for my current value. Current value is simply sum of sales. Now I am going to calculate my mean of my data. I'll use average x function here, and to remove all the implicit filters from my data table, I am going to use all selected here, and my expression is simply just my sales. And now I'll calculate my standard deviation. std stdevx dot p. I'll use all selected here again. Okay, now we are going to calculate our score. So an outlier value is typically a value which has a z score of greater than or equal to 3, and so we are going to calculate that. I am going to use absolute function here because I want to remove all the negative values. Current value minus my mean value divided by standard deviation. This gives me my z score, and I will simply return my score. Okay, now I'll add this into this table. Okay, as you can see, z score of pen is 4.91, which is absolutely correct. So we'll come back to our visual. We will create a slicer here for our filter option, and I am going to do this on single select. Place it here nicely. Okay, so now in this measure itself, we are going to add our switch condition for the selected value of the slicer. So simple switch statement, switch true. Selected value of my filter is equals to show all. If it is show all, I simply want to show all my sales. So current value And my second option is selected value filter data equals to exclude outlier. Now my outlier is someone who has a score of more than 3. So exclude outlier, we are going to exclude the outlier. So we want values which have a score of less than 3. So score has to be less than 3. Only then I want my current value. Alright, so now we are going to use this set score into our y-axis. I'll remove this sum of sales and I'll use my z score. As you can see, I have excluded the outlier, so I'm able to see all my other 4 categories, and when I'm clicking on the show all option, I am getting all my values. So both of these methods are effective, but a logarithmic scale is typically used when you have a skewed data set, when one of the value is a very large outlier, and this method is effective when you still want to emphasize on the outlier and show how relatively big it is as compared to your data spread. Okay, and actually you can improvise this formula according to you. This is a standard formula that the z score has to be greater than or equal to 3, but in your case you can reduce this number or increase it, depends on your data set. Okay, thank you.